and today we will go to section 3.2, which is the reduction of order. In this section, we have just only one single idea, that if we have y1 is a solution to the homogeneous second order differential equation, homogeneous second order, which is in this form, y_' plus pxy' plus qxy is equal 0. And then how we can find out the second solution? Because you know, second homogeneous of second order, I should have two solutions. That if I know, or I have only one solution, how I can find the second solution? The second solution, y2 is equal y1 times the integral of e to the power minus px dx divided by y1 square ex dx. So this is the procedure here, how you can find the second solution, in case you already know the first solution. But first of all, you should have your equation before try to finding the second solution. Should be your equation written in this standard form. The coefficient of y double prime is equal 1. طيب خلينا نشوف الآن examples. This is just on one idea of this section, then we will go to the main sections inshallah ta'ala, starting from section 3.3. The function y1 is equal to e to the power 2x is a solution to this differential equation. Use reduction to find the second solution y2. y1 of x, it's already given e to the power 2x. My equation is written in its standard form. So here the function px is equal minus 4. It's the second solution y2 is equal y1 times e to the power integral minus px dx divided by y1 square dx, which is equal y1, it is 2x times the integral e to the power minus integral px. How much is px? It is minus 4 dx divided by y1 square, which is e to the power 2x square dx. الآن now that becomes e to the power 2x times the integral e to the power integral minus 4x, it is minus 4, it is minus 4x, minus becomes e to the power 4x divided by e to the power 2x square, it is equal e to the power 4x. So that becomes e to the power 2x times the integral 1 dx, which is equal x times e to the power 2x. So the second solution y2 becomes x e to the power 2x. الآن y general, it is c1 y1 plus c2 y2, which is a constant c1 e to the power 2x plus c2x e to the power 2x. This is the general solution for that differential equation. الآن we have an important notice here, that it should be y1 and y2 are linearly independent. And if you remember from previous section, that to be linearly independent, it should be their Wronskian determinant should not be equal 0. الآن let us to check here. Wronskian y1 y2 is equal determinant e to the power 2x 2e to the power 2x x e to the power 2x, وهنا بصير معنا e to the power 2x plus 2x e to the power 2x. A determinant here is equal e to the power 4x, which is not equal 0. So y1 and y2 are linearly independent. So they are linearly independent. طيب نشوف next example. Any question here for this example, by the way? طيب الآن the second example says you have y1 is equal x squared is the solution to this differential equation. But you notice here that we have x squared multiplied by the differential equation y prime. The first thing I have to do is to write my differential equation in its standard form. So this one, it should be written as y prime minus 3x divided by x prime y squared plus 4 divided by x squared times y is equal 0. Which becomes here y prime minus 3 by x py prime plus 4y by x prime y is equal 0. الآن الفirst solution y1 it was x squared. Your px is minus 3 by x. Minus 3 by x. الآن السوليوشن second solution y2 عبارة عن y1 e to the power integral e to the power minus integral px divide by the solution first solution square dx, which is equal x square times an integral e to the power minus integral minus 3 by x dx divide by x square square. الآن here الانتجرال e to the power minus minus becomes plus 3x dx عبارة عن e to the power 3 ln absolute x, which is equal e to the power ln absolute x to the power 3, which is absolute x to the power 3. Well, here this is becomes absolute. This is becomes x cubed. Why x cubed? Since the values of x from 0 to infinity, there is no negative values here, and in this interval the absolute value is the same. Absolute value of x is the same value of x itself. طيب continue here. This comes here عبارة عن x square integral x cube divided by x to the power 4 dx, which is x square integral 1 by x dx, which is equal x square times ln absolute x. And this is becomes also x square ln xy for the same reason, since x belong to the interval 0 to infinity. الآن y2 we already got it, so y general بده يساوي عبارة عن مين؟ c1 y1 plus c2 y2, which is c1 x square plus c2 x square ln lx. So this is the general solution. A reduction of order is quite simple and straightforward. Any question here? Now we will go to the main sections, which is talking about, starting from section 3.3 until the end of this chapter, we will discuss different types of differential equations, and we will see how we can solve them. الآن in this section, what we will learn, we will see how we can solve the homogeneous linear equation with constant coefficient. What do we mean? What do you mean by constant coefficient? I mean here it's the equation written in the form a phi y double prime plus b phi y prime plus c phi y is equal 0. This type of differential equation is homogeneous because it is 0. With constant coefficient, A will be with C constants. Okay? Right. So we will discuss in this section how we can solve such kind of differential equations. A phi y double prime plus by prime plus cy is equal 0, homogeneous with constant coefficient till a, b, and c are a constant solution. All right? طيب. الآن for this differential equation, to solve it, assume y is equal e to the power mx. Then you need y prime and y double prime. y prime بتساوي m e to the power mx. y double prime بتساوي m square e to the power mx. الآن substitute this one in this equation. I mean a phi y double prime plus by prime plus cy بده يساوي 0 implies that إنه m square e to the power mx plus m e to the power mx, of course a, b here, plus c times e to the power mx بده يساوي معنا 0. Now you will see that you can take e to the power mx as a common factor. So that becomes am square plus bm plus c times e to the power mx بده يساوي 0. But now e to the power mx cannot be equal 0. Then the only choice that you will have here to be equal 0 is am square plus bm plus c to be 0. Here the constants a, b, c are already given with you in the differential equation. This becomes a quadratic. M becomes now minus b minus a plus a square root of b square minus 4ac divided by 2a, which is equal minus b minus a plus a square root of delta divided by 2a, where delta it is the discriminant for AC. So that means mainly to solve this second order homogeneous with constant coefficient, mainly is finding the values of m. الآن let us to see what of this one in more details. For any second order differential equation, let us to compare this one with this one. Ay double prime becomes am square. The order of the derivative becomes a power of m. Plus by square, y prime is equal here bm. Power of m1, which is the same as the order of the y. Plus c, y, c. هلا الy here, cy to the power 0, it is c. Here you have the order 0. Now this equation is called auxiliary equation. This one is called the auxiliary equation. Therefore, in general, if you have the equation AYW prime plus BY prime plus CY, it is auxiliary equation. It is this one here. Now you will find the roots M1 and M2. M1, the roots of this auxiliary equation, minus B plus square root of delta divided by 2A. Well, M2 minus B plus, no, here it should be minus. Here it should be minus. الآن we will have 3 different cases. Case number 1 says that if M1 and M2 are real distinct, I mean this is happened in case the discriminant is greater than 0, then the first solution of this differential equation, y1 is equal e to the power m1 of x, and y2 is equal e to the power m2x. Well, the general solution becomes c1 y1 plus c2 y2, which is c1 e to the power m1x plus c2 e to the power m2x. Now, for this auxiliary equation, if in case number 2, m1 is equal m2, and this has happened at when the discriminant 0, the first solution becomes e to the power m1 of x. The second solution is equal x times e to the power m1 of x. That's in case m1 is equal m2. The general solution just c1 y1 plus c2 y2. Now, in case your roots for that equation is a complex root, alpha plus I beta, well, M2 is equal alpha minus I beta. This has happened in case the discriminant is negative. The solution becomes y1 عبارة عن e to the power alpha x cosine beta x, y2 e to the power alpha x في sine beta x. The general solution c1 times y1 plus c2 times y2. This is the main thing on this solution. Therefore, to solve any second order homogeneous with constant coefficients, you have to find out the roots of the auxiliary equation and to see which cases it is belong to case number 1 or case number 2 or case number 3. According to each case, we have a different type of the solution. الآن خلينا نشوف examples. بيقول لي solve the following differential equations. حل المعادلة التفاضلية التالية. The first thing I have to do is I have to write down the auxiliary equation. What's the auxiliary equation here? It is 2m squared minus 5m minus 3 is equal 0. A solution for this auxiliary equation, m becomes minus b minus 5 minus plus the square root of b squared 25 minus 4 times a times minus 3 divided by 2 times 2, which is 2a. Minus 5 becomes 5 minus a plus square root of 25 minus هلا 4 2 8 3 24 طبعا 49 divided by 4. So that becomes 5 minus a plus 7 divided by 4. So M1 عبارة عن مين؟ 5 plus 7 12 divided by 4 عبارة عن كم؟ والM2 5 minus 7, which is minus 2, divided by 4 بعطينا minus half. إذا السوليوشن, so you will have distinct we have distinct real roots. إذا السوليوشن y1 عبارة عن إيش؟ e to the power m1 of x, which is e to the power 3x. والm y2 عبارة عن e to the power m2x واللي هي عبارة عن e to the power minus half x. y general عبارة عن c1 y1 plus c2 y2, which is c1 e to the power 3x plus c2 e to the power minus half x. And that's all. It is very simple, very straightforward. Any question? Any question? Any question for this example? طيب نشوف next example. بيقول لي solve the differential equation y prime minus 10y prime plus 25 is equal 0. Here I have to write down first the auxiliary equation. عبارة عن ايش؟ m square minus 10m plus 25 is equal 0. Find the roots. So this one can be written as m minus 5, all of them square is equal 0, which implies m1 is equal m2, which is equal 5. إذن الآن الجنرال solution y here we have a repeated linear y1 بده يساوي e to the power m1 of x واللي هو e to the power 5x والy2 بده يساوي x e to the power m1 of x, which is x e to the power 5x. So a general solution yg c1y1 plus c2y2, which is c1 e to the power 5x plus c2x e to the power 5x. And that's all. Okay, is it clear? واضح؟ Is it clear this example? واضح المثال هذا؟ طيب نشوف next example. Solve the differential equation. Okay, I will give you 4 minutes to solve this one, and I need you to try and to give me the solution. Can you try this one, please? y prime plus 4 m prime plus 7 is equal 0. I will give you 4 minutes, then we will see the randomly the solution, how we can solve it. مين كمل الحل؟ مين حل السؤال؟ Who solve it? All right, let us solve it. مين حله؟ مين حل السؤال؟ Okay, let us solve it together. هنحله and compare with your solution. هل الauxiliary equation here عبارة عن m square plus 4m plus 7 is equal 0. When you find m, it becomes minus 4 minus plus the square root of b square, which is 16 minus 28. Divide by 2, and that becomes minus 4 minus plus the square root of minus 12 divided by 2. That becomes minus 4 minus plus I, it means here, because the square root of minus 1 square root of 12 divided by 2, which is minus 4 minus plus I for the square root of 12, which is 2 times 3 divided by 2. So you will have the solution, the auxiliary roots m عبارة عن minus 2 minus plus I for the square root of 3. Here you will have alpha is equal minus 2 or beta is equal square root of 3. So our complex numbers. هل y1 عبارة عن e to the power alpha x cosine beta x, which is e to the power minus 2x cosine square root of 3 times x. y2 عبارة عن e to the power alpha x في sine x, which is e to the power minus 2x sine square root of 3 times x. In this case, the general solution yg becomes c1y1 plus c2y2, which is c1 e to the power minus 2x cosine square root of 3 times x, c2 e to the power minus 2x, sine square root of 3x. And that's all. We'll solve it like this. مين حلوها بالطريقة هذه؟ طيب نشوف the next example, solving the following initial value problem. I have here a second order homogeneous with constant coefficient and an initial conditions. طيب نشوف الآن auxiliary equation. What's the auxiliary equation? عبارة عن 4m square plus 4m plus 17. All right. الآن m of course is equal 0. M is equal minus 4 minus plus the square root of b square, which is 16, minus 4 times 17 divided by 2 times 4. So with this is becomes minus 4 minus plus square root of minus 256 divided by 8 واللي هي minus 4 minus plus I في square root of 256 اللي هي 16 divided by 8 وهذا بده يساوي عبارة عن ايش؟ minus half minus plus I times 2. So here you have alpha is equal minus half or beta is equal 2. So a general solution yg directly yg عبارة عن c1y1 plus c2y2 which is equal c1 e to the power minus half x cosine 2x plus c2 e to the power minus half x sine 2x. الآن I need to use here the initial conditions to find out the constant C1 and C2. So since minus 1 is equal y of 0, now substitute 0 everywhere in your yg. It becomes C1 e to the power 0 cosine 0 plus C2 e to the power 0 sine 0. This is implies minus 1 becomes equal e to the power 0 1 cosine of 0 also 1 C1 e to the power 0 1 sine of 0 0 times C2. So that means C1 is equal minus 1. Now y prime of 0 is equal to, you need to find out y prime الآن. هلا y prime is equal. Now derive this. You have to derive it as a product rule here. You have to use the product rule. الأول في مشتقة الثاني الكوزين بصير minus C1 e to the power minus half x sine 2x وهي becomes minus 2 plus الثاني في مشتقة الأول minus half C1 e to the power minus half x cosine 2x plus الأول في مشتقة الثاني it is 2 C2 e to the power minus half x cosine 2x minus half C2 e minus half x sine 2x. Now substitute 0 and equalize it with 2. 2 is equal y of 0. And that becomes y of 0. Substitute y prime, sorry. Y prime of 0. Substitute x is equal 0 at y prime. هلا بصير عندنا ايش؟ minus c2 sin 0 0 plus cosine of 0 بيعطينا 1 e to the power 0 بيعطينا 1 هون بصير معنا ايش؟ minus half c1 cosine of 0 1 e to the power 0 1 plus 2c2 sin of 0 1 e to the power 0 sin of 0 0 e to the power 0 1 بروح معنا ايش؟ 0, which implies that 2 is equal minus half of c1. c1 it is already minus 1 plus 2 less c2, and that becomes here ويصبح معنا قيمة c2 اللي هي بيطلع معنا هون عبارة عن 3 1.5 divided by 2 بيصير معنا 3 by 4. So this is the value of C2. Now substitute it back in your general solution. YG, this is C1, which is minus e to the power minus half x cosine 2x plus 3 by 4 e to the power minus half x sine 2x in this way.
Doctor, I have a question.
Yes.
Y2, the equation of Y2, isn't it sine of x? Why is it sine of 2x?
Because beta is equal to.
So it is sine of beta x.
Beta x, yes.
Okay.
All right. Any question here? All right, next example. نشوف the next example. Also solve the following initial value problem. I have to find out the auxiliary equation first. عبارة عن m square plus m is equal 0. This implies m times m plus 1 is equal 0, which implies either m is equal 0 or m is equal minus 1. الآن first solution y1 e to the power m1 of x e to the power 0x, which is e to the power 0, which is equal 1. The second solution y2 بتساوي e to the power m2x, which is e to the power minus x. هلا yg عبارة عن c1y1 plus c2y2, which is equal c1 times 1 plus c2 e to the power minus x. So this is my general solution. الآن I need to use the initial conditions. 2 is equal y of 0, which is equal c1 plus c2 e to the power 0. That implies 2 is equal c1 plus c2. So you will get this equation. I need to find out again another equation from the second auxiliary second initial conditions. هلا ال1 بده يساوي y prime of 0. How much is y prime here? C1 times 1, it is C1 time becomes 0 plus minus C2e minus x. So that becomes minus C2e to the power minus 0, which implies 1 is equal minus C2. That means C2 is equal minus 1. Therefore, solve this equation now again. 2 is equal C1 plus C2. Yani 2 is equal C1 minus 1. Yani 2 is equal how much? C1 is equal how much? 3. إذا الانيشال الآن ال YG it is C1 which is a 3 minus or plus C2 which is minus 1 times e to the power minus x. So this is the general solution for the initial value problem. طيب نشوف next example. بيقول لي solve the following initial value problem. Y w prime plus y is equal 0. The auxiliary equation here عبارة عن y w prime m w square plus 1 is equal 0, which implies that m square بتساوي minus 1. That means m is equal positive negative square root of minus 1, which is positive negative I. So m is equal 0 plus minus I. It implies alpha is equal 0 or beta is equal 1. y1 عبارة عن e to the power 0x في cosine x. y2 عبارة عن e to the power 0x في sine beta x, which is 1 times x. So ال y1 بتساوي عبارة عن just only cosine وال y2 just only ايش؟ sine. هل ال yg c1 cosine plus c2 sine. Use the initial conditions now to find the constant. The first one 0 is equal y of 0. 0 is equal y of 0 واللي هي عبارة عن مين؟ c1 times 1 plus c2 times 0, which is implies إنه c1 بتساوي معنا 0. Derive it to get y prime. y prime of x بتساوي معنا minus c1 sine x plus c2 cosine x. Here 1 is equal y prime of 0, which is minus c1 times 0, c2 times 1. That means c2 also is equal 1. إذن الآن yg عبارة عن c1 it is 0 times cosine plus 1 times sine. So yg is equal only sine x. واضح المثال هذا؟ Is it clear this example? Any question here? Okay, continue for the next examples. Here we have two known equations. The following two differential equations are important in applied mathematics. Y w prime plus k square y is equal 0, where k is a real number, and y w prime minus k square of y is equal 0. Let us to solve each one of those separately. خلينا نحل الآن كل واحد من هذول بشكل منفصل. طيب نشوف الفيرست equation. هلا الأوكسيلري is m square plus k square is equal 0, which means m square is equal minus k square, and that means m is equal positive negative square root of minus k square, which is positive negative ik. هلا الام sorry الالفا is equal 0 والبيتا is equal k. هلا السوليوشن y1 عبارة عن e to the power 0x cosine kx وال y2 e to the power 0x في sine kx, which is here is equal cosine kx and here sine kx. الآن الجنرال solution yg c1 y1 c2 y2, which is c1 cosine x kx plus c2 sine kx. And we finish this part. Now let us to see the second equation. The second equation, the auxiliary equation for the second one, هي عبارة عن m square minus k square is equal 0. So m square بتساوي k square, that means m is equal positive negative k, which means m1 is equal k while m2 is equal minus k. هلا y1 عبارة عن e to the power m1 of x واللي هي e to the power kx وال y2 e to the power m2x, which is e to the power minus kx. الآن الجنرال solution yg عبارة عن c1 e to the power kx c2 e to the power minus kx. الآن
that's it.
Yes.
مش هنجيب قيمة ال k ولا حاجة؟
لا k is a constant.
So
K.
That's it.
Yes.
Okay.
K is constant. طيب الآن do you remember you know that you know that e to the power k x plus e to the power minus kx divided by 2 is equal what? Cosh of kx. صح ولا لا؟ اجت clear؟ طيب. Also, e to the power kx minus e minus kx divided by 2 also is equal since الx. And if you go back to here, if you know the constant C1 and C2, نعرف الconstant C1 and C2, this one here can be written as yg becomes a new constant C1 times cos kx plus another new constant times sin kx. Because that's depend on those constants C1 and C2 and the constant half. Yes.
I didn't get it. How
You
it's
did not
possible
get
if
why?
yes if
Yes,
if
it is
sine
possible.
is مش فاهم صراحة.
لماذا؟
هو
طيب تعال
الساين
نشوف.
equal e to the power kx
خليك معي.
minus
since
okay.
since خلينا نشوف. since kx plus cos kx شو بده يساوي معك؟ هون half e to the power kx plus e to the power minus kx plus half of e to the power kx minus e minus kx. صح؟
Okay. Yes.
half e to the power kx plus half e to the power kx يبقى يساوي e to the power kx. مظبوط؟
Okay.
half e to the power minus kx minus half e to the power k minus x. It is 0. صح
Okay.
ولا لا؟
Yes.
So for each k e to the power kx you can replace sin plus cos. طيب listen to me.
Yes.
الآن cos kx minus sin kx شو بده يساوي معنا؟ half e to the power kx e to the power minus kx
Plus half
minus half e to the power kx minus e minus kx, which is exactly equal half e kx minus half e kx راح بروح وهنا صار بيصير معنا ايش؟ صار معنا e to the power minus kx.
Okay.
الآن when you have yg is equal c1 في e to the power kx c2 e minus kx, replace the k e to the power kx by its value sin plus cos. Plus cos kx plus c2 times e minus kx, it is cos minus sin.
Yes.
Simplify this one. C1 plus cos plus C2. You will get
تبقى cos kx
C2 times cos plus ايش؟
sin
C1 minus C2 times sinh. Now rewrite C1 plus C2 as a new constant. Call it C1 dash. C1 minus C2, rename it as C2 dash of sinh kx. This is what I meant here. هذا ما قصدته هنا.
Yes.
Any question?
I get. Just let me take a screenshot of this. This will confuse me. Okay, thank you.
Thank you. Is it clear here how we rewrote my solution again with respect to sinh cosh? So if you notice here, when the equation it has positive k square, the solution C1 cosine and C2 sine kx. But in case it is minus k square, it is C1 cosh plus C2 sinh. Is it clear here? All right, now we will go to the higher order equations. الهاير order equations. شوفوا عندي هون. Regarding the higher order equations, with constant coefficient, of course. I mean, an is a constant, an minus 1 constant, a2, a1 is a not, all of them are a constant, real constants. To solve any differential equation with order more than 2, you have to write down it is auxiliary equation. It is auxiliary equation, which is just a normal auxiliary equation. Okay, right. Now you have to find the roots of the auxiliary equation. Of course, here it is very hard to squeeze or to count the cases. I mean, we will have many cases. Now, if the roots of the auxiliary equation are all of them real distinct, then a general solution of this differential equation, it will be C1y1, which is this one, it is y1, plus C2y2, which is it is y2, plus C2y3, which is y3, until this one is yn. It is somewhat harder to summarize the case as the case number 2 or 3, because it is depend on the order. For example, if you have order 5, you have 3 roots distinct and 2 roots بيكونوا معنا repeated. So it is very hard to summarize all the cases as the case number 2 and the 3 in the previous examples. But now, if the auxiliary roots is m1, which is repeated k time, for example, repeated 5 times, the first solution y1, it is m1 of x. The second solution, you have to multiply the first solution by x. A third solution, you have to multiply it by the first solution by x squared. Then you have to continue adding x squared, x cubed, multiplying by the original until you arrive to x to the power k minus 1 e to the power m1 of x. And the general solution, this is y1, this is y2, This is y3, and so, and this is yn. Yes, any question? Okay, you can leave, ya Bilal, don't worry. Now, if M1 is equal alpha plus I beta is a complex root and repeated k times, now it's the same procedure, the general solution as y1 is equal e to the power alpha x cosine beta x. Second solution, you have to multiply it by x. A third solution by x squared, and so on. Also, you have to multiply the sign by the same value. This is the original solution. Multiply the second one by x, the third one by x squared, the fourth one by x cubed, and so on. طيب خلينا نشوف الآن some examples for the higher orders. Do we have time to do examples? Yes, we do. I have y triple prime plus y double prime minus 4y is equal 0. هلا الauxiliary equation عبارة عن m to the power 3 plus 3m square minus 4 is equal 0. طيب الآن how we can solve this one? How we can solve this one? How you can solve the third order differential equation? You see that 1 cube plus 3 times 1 square minus 4 is equal 0. So how you can find the other two solutions? You have to go and divide m cube plus 3m square minus 4 by m minus the root minus 1. So when you find this long division becomes m square plus 4m plus 4. So this equation here becomes, that means m cube plus 3m square minus 4 is equal m minus 1 times m square plus 4m plus 4. الآن we need to find the roots for m square plus 4m plus 4. So that's simplify it again. M minus 1 times m plus 2, all of them square. So the first root m1 is equal minus 1, m2 is equal minus 2, well m3 also is equal minus 3 because repeated minus 2 because it is repeated 2 times. Now how you can find the solutions? y1 بتساوي e to the power minus x. y2 بتساوي e to the power minus 2x. هلا y3 شو بتساوي x e to the power minus 2x. I mean you have to deal with the distinct case as distinct case with the repeated as a repeated case. إذن الجنرال solution y بتساوي معنا عبارة عن c1 e minus x, c2 e minus 2x, c3x e minus 2x بهذا الشكل. All right. Any question up to now? We have to stop here. We have still more examples to do next time, inshallah ta'ala. All right, let us to do the attendance. Can you enter the attendance code, please?